This is Algebra 2, Lesson 8-1, Inverse Variation. Inverse variation is a function in the form of y equals k divided by x, or xy equals k, or x equals k divided by y. You can write it for any variable as long as you don't write it. You can write it for any variable, but k cannot equal 0. That's the most important thing. In an inverse variation, as one quantity increases, the other quantity decreases. A combined variation is when one quantity varies with respect to two or more quantities. And a joint variation is when one quantity varies directly with two or more quantities. Some examples of direct and inverse variation. Inverse variation would be like the time to complete a race decreases as your average speed increases. So if you start driving faster, it takes you less time to complete a race. If you start running faster, it takes you less time to complete the race. Direct variation says as the force with which you throw a ball increases, the distance it travels increases. If I throw a ball with force of 3, it's only going to go so far. But if I throw a ball with a force of 12, it's going to go a lot farther because as one thing increases, the other thing decreases. An inverse variation is a curved graph. It looks a lot like this graph here on the screen. It's the product of every x value with its corresponding y value is the same number. That's how you can tell if something is in inverse variation. For example, if we were to multiply 3 and 8 here, 8 times 3 is 24, 6 times 4 is 24, 12 times 2 is 24, 24 times 1 is 24. X times y has to equal the same constant in order for it to be inverse variation. In direct variation, the ratio of every y value to its corresponding x value is the same. So if you wanted to see if something was direct variation, you would divide y by x and see if that number comes out the same every time. For inverse variation, you multiply x and y and see if that number comes out the same every time. So inverse variation looks very much like this. It's a curved graph with branches going that way. So if we wanted to identify direct and inverse variation, and we wanted to see if the relationship between, if they are that. So if I was to look at this one, this very first one here, if I took 1 times 52, that is obviously 52. If I do 2 times 34, that is obviously 68, and 52 does not equal 68. Therefore, this is not inverse variation. Right? What I should have started with is taking a look at this. Y goes down, x goes up. So it's either inverse variation or it's neither. If it's not direct variation, because direct variation says as one value goes up, the other value goes up. Here, x is going up, but y is going down. Therefore, it cannot be direct variation, so it has to be inverse variation or neither. Since the x times the y value is not constant, this is neither. Let's look at this second one here. If I look at this, x is increasing. This is going up, this is going up, this is going up. So this is increasing, going up. Y is decreasing, this is going down. This is going down, this is going down. So now I'll look at the, I'll look and see if they have a correlation here. 0.2 times 0.8 is 0.16. 0.4 times 0.4 is 0.16. 0.5 times 0.32 is also 0.16, and 1 times 0.16 is also 0.16. So this is inverse variation. And we could write the equation for that variation as y equals k over x. Okay, so y would equal 0.16 over x. And that would be the inverse variation for this particular equation. Now, if you know something is inverse variation, you can determine things and you can write an inverse variation equation. Suppose that x and y vary inversely and x equals 3 when y equals -5. We're going to write the function that models the inverse variation. Since we know inverse variation is x times y equals k, if x is 3 when y is -5, we can solve that to far out k, so that's going to equal k. So -15 equals k here. So our inverse variation equation is x times y equals -15, or y equals -15 divided by x, or x equals -15 divided by y. You just solve it for the different variables. So either one of those 3 forms are all inverse variation. These are all the same form of inverse variation. They're just different ways of writing the same form. Okay, so suppose x and y vary inversely, and x is 7 and y is 4. Let's write that function. So xy equals k. 7 times 4 equals k, so 28 equals k. So we either have xy equals 28, y equals 28 over x, or x equals 28 over y. So those are the three forms of that inverse variation. All right, and there's a typo on this. We're going to just cross off this last value here. So cross out that last value because that's not supposed to be there. That was from a different table, and I accidentally put it in here. So if it says the table shows a time in t in minutes, it takes a group of n students to remove the debris from an average size yard. All right? That's pretty one. We had a major windstorm. Forgot about that. After a major windstorm, your math class volunteers to remove debris from yards. Okay? So if only one student is doing it, it will take them 225 minutes. If 3 students are doing it, it will take them 75 minutes. If 5 students are doing it, it will take them 45 minutes. So let's check this variation. As the number of students goes up, the time in minutes goes down, so it looks like it's inverse. Let's check and make sure that we know the constant of variation. So that's going to be 225. If we took 3 times 75, that's 225. If we took 5 times 45, that is also 225. So there we have, it is constant. So we do have inverse variation here. So our variation equation, we're going to use T and N, okay, because that's what it will do. The time, based on the number of students, is going to equal 225. Okay, so what function models the time needed to clear debris from an average size yard relative to the number of students who work? Okay, so we're going to write it for time, because it wants to write it what function time needed. So this is the general form. We're going to solve this for t, so t is going to equal 225 divided by n. That's the form they asked us to write it in, because they asked us to write it. They want us to model the time needed, okay, based on the number of students, so t equals 225 over n. The next question asked, how many students should there be to clear debris from an average size yard in at most 25 minutes? So t equals 225 over n. So we know we don't want to be more than 25 minutes, that's the max, so 25 equals 225 divided by n. And we'll solve this equation for n. So simply multiply both sides by n. And then will cancel, and you'll have 25n equals 225. Divide by 25. And n will equal 9. So you should have 9 students. It should take 9 students to get the debris out in 25 minutes. There we go. All right, now let's take a look at some other types of variation. You've seen many variation formulas in geometry, like the formula for the perimeter of a square, and those are simple direct variation. Okay. Others, like the formula for a cone, relate 2 or 3 or more variables. These would be what we call combined variations. Okay. If I have y varies directly with the square of x, that would be y equals k times x squared, because it's a direct variation, so you're just going to multiply them together. Y equals k times x squared. Y varies inversely with the cube of x, is going to be y equals k divided by x to the third, okay, which would be the cube of x. Okay, how about z varies jointly with x and y? That means z equals kxy. Remember, every single time here, k is your constant of variation. These are considered to be combined variations. They can be a combined direct variation, they can be a combined inverse variation, it can be a joint variation, okay, which means you're multiplying. It can be a combined joint and inverse variation like this, where z varies jointly with x and y and inversely with w. So jointly means we're going to multiply x, y times k, but inversely means we're going to divide it by w. And in the last one, z varies directly with x and inversely with the product of y and w, means z equals k times x, that's your direct variation, divided by the inverse, the product of your inverse, w and y. So we're going to look at some variations here. We're going to try to determine what type of variation they are. So if we look at this, we've got p equals ktn. Remember, k is always your constant of variation. So if we look at this, everything's multiplied, so that's joint variation. So we have a joint variation, and we're going to explain that variation. So basically we have P varies jointly with T and N. P varies jointly with T and N. The second one, M equals KY divided by XN. So, M varies directly with Y, but inversely with X and N, and those are multiplied together, so that would be M varies jointly with Y and inversely with the product of X and N. Okay, M varies jointly with Y and inversely with the product X. And last one up here, we have V equals KRM divided by Z. So our constant of variation varies jointly with R and M, but inversely with Z here. So V varies jointly with R and M, and inversely with Z. So basically, if it's multiplying its joint variation and it's dividing its inverse variation, it's pretty simple to figure out. So let's use these combined variations here. The number of bags of mulch you need to mulch a planting area varies jointly with the area to be mulched A in square feet and the depth of the mulch D in feet. If you need 10 bags of mulch, 120 square feet to a depth of 3 inches, how many bags do you need to mulch 200 square feet to a depth of 4 inches? Okay. So, if I'm going to let B equal the number of bags, this is a joint variation. I know that the number of bags I have is going to equal my constant of variation. It says it varies jointly, didn't say inversely, jointly with the area to be mulched, okay, the area to be mulched, and the depth that it needs to be mulched in. So it's B equals K times A times D. Now I'm just going to plug in what I know. It takes me 10 bags to mulch 120 feet, 3 inches. Okay? So 10 equals 360K. I solve for K, divide by 10, divide by 360, 136 equals K. So there's my general equation. So B equals, so that's my constant of variation. So B equals 136 AB. That's my constant of variation. So now how many bags am I going to need to do 200 square feet to 4 inches? So B is going to equal 1 over 36 times 200 times 4. Right? And when you multiply that all out, you get 22 2/9. But I can't buy 2/9 of a bag of mulch, so I will need 23 bags. Because I can't buy 2/9 of a bag of mulch. I'll have to go all the way up to that 23rd bag. So I'll need 23 bags to mulch. Let's look at another one. Gravitational potential energy, PE, is a measure of energy. Potential energy varies directly with an object's mass and its height in meters above the ground. Physicists use G to represent the constant of variation, which is gravity, and if you didn't know, G is equal to 9.8 meters per second. Okay? When something falls, gravity pulls it at 9.8 meters per second. Okay? Or 16 feet per second. That's basically what it's called. So, how much potential energy would a 41 kilogram diver have standing on a 10-meter platform? So, potential energy is going to equal G, which is the gravitational energy. Okay, constant variation is G, times, in this case, the object's mass and his height, because it varies directly, so it's all multiplied together. It's joint variation all multiplied together. So the potential energy will equal the constant of gravity, which is 9.8, times the mass of my diver, which is 41 kilograms, times the height he is above the ground, which is 10 meters. Okay? So you multiply all that together with the potential energy that this diver has is going to be 4,018, and this is measured in a measure called joules. And it's a scientific measurement for how much potential energy something has. So he has the potential of having 4,018 joules of energy when he dives off that platform. All right, quick review here. Direct and inverse variations show a relationship between two quantities. For direct variation, y equals k times x, remembering that k cannot equal 0. The absolute value of both quantities increases together, and the graph of this is a line. Okay? Because in direct variation, as one value increases, the other value increases. So it's a line. Okay? The quotient of the y value and the corresponding x value is constant. So when you divide y by x, we get a constant. For inverse variation, y equals k over x for any non-zero constant k. The absolute value of one quantity increases as the absolute value of the other quantity decreases. The product of the y value and the corresponding x values is constant. Okay. In a combined variation, one quantity varies with respect to two or more others. So z varies jointly with x and y, you have z equals kxy. If z varies jointly with xy and inversely with w, you get z equals kxy over w. And last but not least, if z varies jointly with x and inversely with the product of w and y, it's z equals k times x divided by w and y. Okay. So this is inverse variation.